In this problem, we're talking about a water balloon and a dart being let go at the same time. The water balloon is following a parabolic path, and this is the equation that it follows. And the dart is following a straight path, and this is the equation that we're given for that. And the main point of this problem is to kind of see where the two objects would cross paths. So the first thing it asks us to do is graph each equation on the coordinate grid. Before I do any graphing, I want to start with a parabola. Usually I like to start with the easier of the two equations, but there's a reason I want to start with the parabola, and that is because it's going to tell me if I need to scale my graph. So I am going to make a table of values. I'm going to do this over here. Now something else is going to change here. When we graphed parabolas previously, I would say use negative b over 2a to find the middle of your table, and then have a total of 5 points. And that worked just fine for our purposes before, but now that we are talking about it's the path of this balloon, this water balloon that's going in the air, I need to know where the balloon starts, and I need to know when it hits the ground. So I am going to always start my table at 0, and pretty much this parabola is always going to start at 0, 0, because it's being thrown from the ground. That's going to be like right here. And then I need to know everything that happens in between until it hits the ground again. So I need to have as many points as I need to see when y gets back to 0. So y is going to start and stop at 0, and that's all the points that I need. So I'm going to go to y equals on my calculator, and if I scroll down, I can see that at 8 we are back at 0. So when x gets to 8, our y value is back to 0. So I need to now go through and copy down 1 through 7 so that I can see what all those points are. All right, so I'm copying down all of my y values. So at 1, it's 7, 2, 12, 3, 15, 4, 16, and then my y values repeat. So 12 and 7, and then I'm back down to 0. So if you look at our y values, the biggest y value that we get to is 16, not 15. So we need to make sure our graph can go up to 16. So this graph goes up to its 10 boxes. So if we go by 2s, that should be enough to make sure that we can fit in all of our points. Now it would be really tempting because my x values only go up to 8, so that should be fine. So it would be really tempting to do that, but we're not going to. I'm going to keep the scale the same, so the x-axis is also going to go by 2s. And the reason is because when we do our graph for the line, I don't want to have to be worried about when I do my rise over run. I want my scale to be the same so that I can just count boxes. I don't have to worry about worrying about the scales being different. All right, so let's go ahead and graph our parabola. So I have the point 0, 0, that's already done. 1, 7 would be in the middle, like half a box, and then up 3.5 boxes. 2, 12 would be here. 3, 15 would be about there. 4, 16, and then we're going to go back down. 5, 15, 6, 12, 7, 7, and then 8, 0. So this is what the path of the water balloon looks like. All right, now let's do the path of the dart. So this one's not going to be as complicated. We don't need a table of values. For this one, I have a slope of -1 and a y-intercept of 8. So here's my y-intercept. And when I do my slope, I can still just do down 1 box and right 1 box, even though I'm technically going down 2 and right 2. It's all the same. So I'm going down 1 and right 1. And it looks like when I connect the dots here, these two things are going to cross in 2 places. The first one is right here, and that is at the point 1, 7. And then the second one is when they're both going to hit the ground at the same time. So that would be at the point 8, 0. Now part C asks us to solve the same system of equations, but we're going to do so algebraically. So as long as we did this correctly, we should get the same answer. So the first thing I'm going to do is set this up so that I have both of my equations written together. And what I want to do is I want to take this thing that's quadratic, and normally I would put it on the right side, but because my x squared is negative, I'm actually going to put it on the left. So normally I would say take what I have in the box and put it into the top equation, but I'm going to do things a little differently. I'm going to take this and I'm going to put it on the left. So I'm going to do negative x plus 8 equals negative x squared plus 8x. I want to get 0 on the right side, so I'm going to add x squared to both sides, and that's going to be like off to all the way to the left, and then I'm going to subtract 8x. So here's what we have. Positive x squared, which is what I wanted, that's why I did things in a different order, minus 9x plus 8, and then it equals 0. So now here I'm going to use factoring. And the reason I'm going to use factoring is because it is factorable, and in my opinion, it's less work to be able to do it this way. So I need two numbers that multiply to 8 and add to negative 9, which would be negative 1 and negative 8. So my polynomial factors into x minus 1 and x minus 8. If I set each one of these equal to 0, I'm going to get x equals 1 and x equals 8. And if you'll notice in part B, x equals 1, x equals 8. So we're off to a good start. Now we need to plug those two x values back in and figure out what the corresponding y values are. So I'm going to do x equals negative 1 and then x equals 1 and x equals 8. All right, so I'm going to choose to plug it into this equation. I think this one will be less work for us. So I have negative x plus 8, and negative 1 plus 8 is 7. So my first solution would be 1 comma 7, which matches up here. And then I'm also going to do y equals negative x plus 8, which is 0. So my other solution would be 8 comma 0, which is also my other solution here. So two different ways solving the same problem, but we come up with the same solution either way. In this problem, we are talking about a pelican that's flying over the air, over the water. So I'm going to attempt to draw a picture here. So here's the water, and there's a pelican that's flying up here, and I'm really bad at drawing birds. So here's the pelican that's carrying a crab. So this is going to be the crab. We'll just pretend that red dot's the crab. And it drops the crab, and it starts to fall down to the water following the path of a parabola. At which point, the pelican decides that it's going to like nosedive to the water, and so it takes a path like this. And the question is the seagull going to catch the crab before it hits the water? So I have two equations. This equation here, that's the path of the crab falling out of the pelican's mouth. And then the other equation is this right here, and that's the path of the seagull. Oh, I just realized that it says pelican and seagull. But either way, the bird that flies in a straight path to see if he can catch the crab. So what I'm going to do is I'm going to solve this algebraically. So I'm going to set these two things. Actually, the first thing I'm doing is just write them down. So I'm going to say y equals negative 16t squared plus 30, and then y equals negative 8t plus 15. All right, so I need to set these two things equal, and I'm going to have to solve it. So what I like to do, I usually like to have the quadratic term on the left, but because it's negative, I'm going to keep it on the right. So what I'm going to do is take this thing here, and I'm going to replace it into the top equation. So what I'm going to get is negative 8t plus 15 equals negative 16t squared plus 30. Now I need to get 0 on the right side, so I'm going to add 16t squared to both sides, and I'm going to subtract 30. So everything on the right cancels out, giving me 0. On the left, I have 16t squared minus 8t minus 15. All right, so at this point, I have two choices. I can either figure out this as a grouping diamond, or I could use quadratic formula. I am going to choose to do a grouping diamond because that's something we haven't seen in a little while. So first thing I need to do is my diamond. The top here is going to be 16 times negative 15. And remember, you're doing that because the number in front of t squared is not 1. So that number is going to be negative 240. And then on the bottom, it's going to be negative 8. So I'm looking for two numbers that divide into two numbers that multiply to negative 240 and add to negative 8. And those numbers are negative 20 and positive 12. So at this point, I'm going to rewrite the first and the last terms. So 16t squared and then minus 15. And in the middle, my new numbers here, I'm going to rewrite those so that they have the same variable as the middle term. So it's going to be minus 20t plus 12t. And now I need to do a grouping problem. So I'm going to put parentheses around the first two and the last two. And by the way, this should be equal 0 still. From the first group, I can take out a 4t, leaving me with 4t minus 5. From the second group, I can take out a 3, leaving me with 4t minus 5 again. And so when I factor this completely, I end up with 4t plus 3 and 4t minus 5 equals 0. So at this point, I can solve both of my linear equations. 4t plus 3 equals 0 and 4t minus 5 equals 0. These are a two-step equation, so I would subtract 3 from both sides, giving me 4t equals negative 3, and then divide by 4. And I am going to choose to give this as a decimal, so I'm going to say negative 0.75. And the reason I'm choosing to do a decimal is because t represents time. How many seconds are we talking about here? So it makes more sense to me to talk about seconds as negative 0.75 instead of negative 3 over 4. And then for my other equation, I'm going to be adding 5 to both sides. And I'm going to kind of scoot over a little bit here. So 4t equals 5, divide by 4. So our other solution would be 1.25. All right, so I have two solutions for t. However, one of them doesn't make sense. Like I said, t represents time. We can't have negative time. So this negative 0.75 actually gets crossed out. So our only viable time solution is 1.25 seconds. So I'm going to take that 1.25 seconds and plug it back in. And I'm going to see what the y value is. And we'll talk about that in a little more detail once we actually have a solution. So I'm going to plug it into the linear. So I'm going to do negative 8 times 1.25 plus 15. And let's see, if I do that in my calculator, it gives me 5. Okay, so let's talk for a second. My solution here is 1.25 comma 5. The 1.25 represents time. So that's saying after 1.25 seconds, and then my y value represents the height, or you could also say the distance above the water. So since this is a positive number, what it means is that the seagull will be able to catch the crab 5 feet before the crab hits the water. So the answer to the question is yes, he will be able to catch the crab 5 feet before it hits the water. In this problem, we are talking about stock prices of the Apple stock and the Microsoft stock. So we're given two functions. One represents Apple stock, which is this one. And then this one represents the Microsoft stock. And it's talking about over the same amount of time. We're talking about the prices to the nearest dollar, and we want to know when both of them would be the same value. So this is just a system of equations. I'm going to set the two things equal to each other. I'm going to write the 0.75x squared minus 6x plus 20 on the left, and then the 2.75x plus 1.5, or 1.50, I guess, on the right. And I like to do that because now I have my positive x squared term on the left. So my object here is to try to get 0 on the right side. So I'm going to subtract 2.75x from both sides, and I'm going to subtract 150 from both sides. So everything on the right cancels out, and on the left I have 0.75x squared minus 8.75x plus 1850. And that all equals 0. Now at this point, usually I would say you can either factor or you can use quadratic formula. I think factoring is kind of out of the picture. Even if we multiplied this whole equation by 100 so that we'd get rid of our decimals, our numbers would be astronomically large and it would take forever to figure out our numbers. So I think quadratic formula here is our best bet. So I'm going to say that A is 0.75, B is negative 8.75, and C is 1850. So now I'm going to plug those into the quadratic formula, and we're going to get decimals. And you'll notice that it says at the very last sentence, state all prices to the nearest dollar. So when we get our solutions, they will be decimals, but we're going to round them to the nearest whole number because that would represent the nearest dollar. Okay, so we are going to, let's see, negative b would be negative 8.75 plus or minus negative 8.75 squared minus 4 times 0.75 times 1850. So this looks really complicated. And then over 2 times a, which is 0.75. So the first thing I'm going to do, just to kind of clean things up a little bit, and this part, if you don't need to do this, it's fine. I'm going to write positive 8.75. I'm going to figure out what goes under the decimal, or I'm sorry, under the radical, and then we'll figure out what's in the denominator. And we'll fill that stuff in before we worry about putting anything into the calculator. All right, so under the radical, we would have 21.0625, and then in the denominator we would have 1.5. So now it just looks a little bit cleaner for when we put it into the calculator. So at this point, I'm going to split this up into two different equations, I guess. So the first one is going to be 8.75, oops, I forgot my 7, plus the square root of 21.0625 over 1.5, and the other one will be the same exact thing but minus the radical. Okay, now from here what we're going to do is type this nonsense into our calculator and we'll get a decimal. So I'm going to type in 8.75 plus the radical and then divide it by 1.5, and that gives me 8.8929 blah blah blah. Okay, and then I'm going to do the exact same thing, but I'm going to do 8.75 minus the radical divided by 1.5, and that gives me 2.7737 ... Okay, now the first thing we need to talk about, well, not the first thing, but one thing we need to talk about is what x represents. It tells us up here x is the number of months. Okay, so when it said that we needed to round all the prices to the nearest dollar, it wasn't talking about these numbers that I have written in blue. It was talking about the numbers that we're going to get as our y value. So when I plug these in, I'm going to say maybe let's round these to one decimal place, 8.9 for the first one and 2.8 for the second one. So I have two x values talking about how they're going to be the same price at 8.9 months, and they'll be the same price at 2.8 months. And now we have to figure out what that price is. So I'm going to plug some stuff in now. So I'm going to say y equals 2.75, I keep forgetting the 7, times x, which in this one is 8.9, and then that's plus 150. So I'm going to plug all of this information in, and that gives me 25.975. Now this represents money, so if I'm rounding this to the nearest dollar, it would be 26. Okay, now let's figure out the other one. I have y equals 2.75 times this x value plus 150. So 2.75 times 2.8 plus 150, that gives me 9.2. And if I'm rounding it to the nearest dollar, it would be $9. Okay, so here's the situation. I have two solutions, and what it's telling me is that after 8.9 months, the two stocks will be the same value at $26. And then after 2.8 months, which is it would actually happen first, they would also have the same value, which is at $9. So there are two solutions. There are two times when these stocks would have the same price.